Now that you've had a chance to try adding in a factory and carbon dioxide into your greenhouse gas base model, we're going to show you one example of how to create that code. Keep in mind, though, that there are many different ways to code a similar idea. So this is not the only way, and you've probably done it differently, and that's absolutely fine. We're starting out with the model you've already remixed, and you've already added in a carbon dioxide breed and a factory breed. Now we need to start off by creating that factory. So in order to create that factory, we want it to appear when setup is pushed. We'll look for the create do block and add it in below the create one sun. Make sure it's on the outside of that create block. Now for now we just want to create one factory. So I'm going to select factory, and then we're going to want to give that factory some traits. For example, we want to give it a color. Let's give it the color red. And we're also going to want to give it a shape, something that looks a little bit like a factory. So let's see, let's set my shape to a built-in shape. Well, let's go with castle. Next, we're going to want to test this out. Let's see, first of all, before we move on, let's see if a factory actually appears when we hit setup. And then I'll hit setup. And there's a factory. It's really small though, so I think we should actually give it a size and make it a bit bigger than that. Let's go back into traits and pick a size. So let's set my size to be, but let's set it to 3. Now let's check that again. It's always a good idea after you've done a little bit of code to go back and check and make sure it's working. Now you notice every time we hit setup, it always appears in the same place, in the center. If you want to give the model a little more randomness, we could make sure that it shows up at a random place every time by adding a scatter block. So what's going to happen is that the factory is going to be created and then it's going to scatter. Yes, there it goes. Factories in every which place. Fantastic. So the next thing we want from the factory is we want to give it a behavior. And the behavior we want to give the factory is for it to emit CO2. Emitting CO2. Let's remember other things that created a different breed. So solar energy created breeds before. How did it do that? This is always a good way of shortcutting your code. So for example, solar energy, it called a procedure in which reflected energy and heat could be created. So we're going to take one of these procedures with us, copy, and we'll take it back to the factory and paste. We're going to give it a different name though. We'll call it emit CO2. Instead of creating a reflected energy, we're going to create one CO2. We're going to give it a drab color, let's say gray. Change its shape to, let's say, a pyramid, and its size to 2. Okay, so now we have a procedure set up for emitting CO2. What we need to do is call that procedure within something. Again, let's look at how we did it in solar energy. We did it when a while forever is toggled and using all of these nested conditionals. I think that's probably not exactly what we want this time, so I'm going to go ahead and do something different for this one. I'd like to control this factory and not let it run the entire time, so I'm going to create a when pushed button for the factory. So I'm going to create a widget that says when factory is going to run. Before I do anything down in the code, I need to add it up in Spaceland. So we're going to call it a push button, and we're going to call that run factory. That way I can control when the factory is emitting CO2 by pushing that button. Great, so now it should show up here when run factory is pushed. And then we need to call that procedure. So let's go into procedures to call emit CO2. So from what this looks like now, hopefully if we check the code, the factory will show up, and when we hit run factory, CO2 should be emitted. But at the moment, the CO2, it doesn't have any behaviors, so it's not actually doing anything. So we might not be able to see anything happen. So let's go ahead and give it a behavior for when it is emitted by the factory. Now we're going to want it to rise, hover, and then decay. So those are three different aspects. Let's see a different agent that had similar behaviors that we might want to copy. For example, heat. So heat, up until it reached a Z of 20, would go up by 0.5 every time, and then when it reached to 20, it would delete. So we can make use of this code. So we're going to say this part is fine. If my Z is less than or equal to 20, I'll keep going up, and else, if you get to there, I don't want to delete it, I want it to hover, so I'm going to pick a procedure, and I'm going to call that procedure hover, so that I'm calling it within here. Okay. We want to have the carbon dioxide hovering once it gets up a certain distance. By hover, what do we think we mean here? Well, what I think I mean with hover is I want it to be moving side to side but not going up or down, and just moving around a little bit but not too much in a random way. So that's basically a wiggle, which we've done before. Let's say we want it to be going not very far away. We'll do a left by and right by random number of degrees, and that should be our wiggle. Let's make it quite an open wiggle. We don't want it to be too directed, so we'll say 45. Okay, so this should be enough now that if we go and test our code, we should be able to see something happening. Let's hit setup again. The factory's over there in the corner. I'm going to hit it a couple more times till it's closer. Okay, it's right there. Now let's hit forever. So far so good. The sun's emitting its solar energy, which is turning into reflected energy or heat when it hits the ground. Now let's hit run factory and see if carbon dioxide shows up. Oh, we had something show up there. One little carbon dioxide. Can hit another one, and oh, we get another one showing up. Let's zoom in a little, see what's happening. So far so good. So it's only one at a time, but so that just might not be exactly what we want to show, but so far it means our code is working. Okay, so there's a few things we want to happen as well. We want the heat to become trapped in some way because of this carbon dioxide. In order to code that in, we need to find the collision block. We're in the heat tab, so we want to say on collision with carbon dioxide, do something. Now we want to model the effect that carbon dioxide has on heat. So carbon dioxide temporarily traps infrared radiation. I'm going to model that by having the heat go back down to the surface and then some of the time creating a second heat. That will mean that that heat agent will stay in the world longer than it would have if it had not interacted with the carbon dioxide. So on collision with carbon dioxide, if I'm the heat agent, I'm going to go back down. So let's set my altitude back to 0. So I'm going to go running back to the ground. And what I'd like as well is that some of the time I'd like to actually create another heat. We're going to say create one heat, but we want this only to happen some of the time. So we need to find an if statement to put it all in. So here we go. So we'll say if a random 100 is less than or equal to 10, that will be about 10% of the time we'll create one heat. So let's give it some traits. So we remember that the heat color was red, and its shape was a sphere, and its size. Let's see what this looks like now. Let's hit forever. We're probably going to need to add a little more CO2 in here so we can see this effect. So I'm going to hit the run factory. I can't see much behavior happening there, so I'm going to change something in the code for carbon dioxide. I'm going to say that it should hover at a lower altitude than the one at which the heat is disappearing. The heat is disappearing when it gets to 20, so it might be that it's disappearing before the carbon dioxide has a chance to interact with it. So let's see if that makes any difference. Oh, there, we just saw it happen. This heat molecule went down after it hit one of the carbon dioxides. Excellent, so we now have the collision working with carbon dioxide. What we now want to do is add in a decay procedure. So carbon dioxide in the atmosphere doesn't last forever. It does eventually decay, and we want to represent this in the model. So I'm going to name this procedure decay, and we're going to use a conditional to decide how often a molecule will decay. So let's say, using our random, let's give it a very low probability this time though. We don't want it to happen too frequently. So let's say 1 out of every 10,000 times the agent will delete itself. And that will be decay. Now we want decay to happen randomly. We'll call it within the forever, outside of this block, so that it could happen at any time. We now have the basic elements of the factory and carbon dioxide model that we wanted to create. However, I'm going to introduce a few extensions to make it run a little bit more the way I'd like it to. So one of the things I want to do in this model is I want to be tracking not just heat, but also carbon dioxide. That way I can test out to see if the carbon dioxide is decaying and to monitor how many there are in the model. So for that I need to add in widgets. I need to add in a new line graph widget. We'll call that CO2 levels. And I need to add in a new data box widget, which we will call CO2. All right, so we have these widgets. I'm just going to move these guys around so that they're all in a similar place. Now we need to add code in for these widgets. So we will go down to the code. Luckily, we already have a data box and a graph in our world, so it shouldn't be too hard to add in more code for that. So what I'm going to do is I'm going to actually select this code and add it back in down here. That's a much faster way of doing it. So we'll go CO2 for series 1, which we'll have to rename. And the x-axis will still be the clock, and the y-axis will count CO2 within 200 steps. The CO2 data box will also count CO2. We also need to make sure that we clear the line graphs and the data box every time, so I'm going to copy this code across so that we're making sure that we do the same thing for CO2 that we have done for heat. And I would like to edit this CO2 graph. I'd like the x-axis to be called clock and the y-axis to be called CO2. And the series, I'm going to rename that CO2 levels. And I'm just going to hit forever, and hopefully this should start updating. So if I add in CO2 here, it shows up, and eventually some of them are decaying. So our graphs and our counters are working. Excellent. So let's go and check out and make sure that we can hide the graph and show the graph with our push buttons. Let's see if that works now. Show graphs, hide graphs. Now the other thing I want to modify here is the fact that we're only creating 1 carbon dioxide each time we hit run factory. That doesn't seem realistic to me, so I want to be able to control this in Spaceland. I'm going to create a new widget for that. Let's make sure our interval sizes are all the way we want them. All right, and let's give it a larger maximum, let's say 50. Once we've added the slider in, we need to add in the code. So instead of creating 1 CO2 here, we're going to find the slider value, and select number of CO2 emitted slider. So now we're controlling that code with the slider. We'll set it up, hit forever, the sun is going, run factory, boom, 10 carbon dioxides have shown up. So if we move this up here to 28 and hit run factory, 28 should show up. They're all showing up together and then they're spreading out as they wiggle. There's only one more modification I absolutely would love to add in here, which is another widget. I'm going to add in another data box, and I'm going to call this one clock. And I'm going to set this clock to show me what the clock is at in the world. Code right here. And I'm going to say set clock to, and I don't need this, I'm just going to set it to clock. And I will make sure to clear that clock to 0 when we hit setup so that it all starts over again. Now, why did I do that? Basically, it's going to help us track how long the model has been running for. And if you wanted to do an experiment, you could say, I will run it for this many ticks, which is the number that's in the clock, and then stop it. All right, you have every element here. You probably have done this in a different way. Every time I do this one, I do it in about 10 different types of ways. So enjoy coding and go back and play with your model some more.